Have you ever thought about, like, what actually makes one belief, reasonable and another, like, totally out there?
Yeah,
It's a pretty fundamental question when you get down to it.
absolutely it is.
Like, imagine someone says they believe George Eliot wrote, like, more than 6 novels at the same time, but also somehow less than 4.
Oh, wow.
It just sounds ridiculous, right?
Yeah, that's pretty hard to wrap your head around.
But as philosophers, we can't just say, nope, that's crazy. We need like a solid principle to point to and explain why that belief is irrational.
Right. We need to get at the underlying justification.
Exactly. And that's
Ooh.
kind of the puzzle we're going to tackle in this deep dive.
This is going to be fun.
And we're doing this deep dive with you specifically in mind.
Yeah, thinking about our listeners who are really into this stuff.
Yeah, because this gets into some deep epistemological waters.
Oh, it does, for sure. It really strikes at the core of how we think about knowledge and justified belief.
And you know what's cool?
What's that?
The approach we're going to explore today offers a really, elegant and powerful way to dissect these questions.
I completely agree. It's called epistemic utility arguments.
Epistemic utility arguments.
Yeah, it's a mouthful, but it's a really neat idea.
So what's the basic gist?
Well, think of it like this. We're trying to figure out how rational our beliefs are.
Okay.
And we do that by looking at their epistemic value.
Epistemic value.
Basically, how good they are at getting us to the truth.
So it's all about how well our beliefs line up with reality?
Exactly. And to do this, we actually borrow some tools from decision theory.
Decision theory, so like how we make choices in everyday life.
That's the idea. It's surprisingly connected.
Okay, so that's our mission for this deep dive. We're going deep on epistemic utility.
Unpacking all the details.
And figuring out how it tries to set the standards for, what we should believe, how confident we should be, and even the right ways to form those beliefs in the first place.
It's about getting at the norms of rational belief from the ground up.
And our main guide in this exploration
Our roadmap
is the Stanford Encyclopedia of Philosophy entry on epistemic utility arguments for epistemic norms.
It's a fantastic resource.
Yeah.
Really in-depth and rigorous,
Perfect for our audience.
Exactly. It lays out the whole field, all the arguments, the debates, with real philosophical precision.
So listeners, if you want to dive even deeper after this, you know where to go.
Definitely check out the SEP entry.
Now, the SEP entry starts by making this analogy to decision theory.
Right off the bat.
Seems like that's a crucial starting point for understanding this whole framework.
Oh, it absolutely is. It lays the groundwork.
So can you walk us through that analogy? What's
Yeah.
the connection between decision theory and this idea of epistemic utility?
Okay, so in regular decision theory, you've got a few key elements.
Okay.
First, you've got the possible states of the world.
The ways things could actually be.
Right. Then you've got the actions an agent can take.
What you can actually do.
Exactly. And then there's the utility function.
That's where things get interesting.
It is. The utility function assigns a value to each possible outcome.
An outcome being like what happens when you take a specific action in a specific state of the world.
Precisely. So it's like a way of measuring how good or bad each outcome is.
Okay, I'm with you so far.
Good. Now, epistemic utility theory borrows this structure and gives it a twist.
A twist. How so?
Instead of actions, we're interested in epistemic states.
Epistemic states. What are those?
Things like our beliefs, our levels of confidence, the whole spectrum of how we think about what's true.
So instead of choosing what to do, we're looking at what we believe.
Precisely. And instead of a regular utility function,
We have an epistemic one.
you got it. An epistemic utility function measures the purely epistemic value of an epistemic state at a world.
So how good that belief is from the standpoint of knowledge and truth.
Exactly. And this helps us understand why certain ways of believing seem more rational than others.
Because they tend to have higher epistemic utility. They're better at getting us to the truth.
That's the core idea.
I see. And we even have epistemic disutility.
Right. The flip side,
So that's like the badness of a belief being wrong.
the epistemic cost of being out of sync with reality.
Gotcha. So the analogy is clear. Now, how do these epistemic utility arguments actually play out? Like, what's the general structure of the argument?
Okay, most of these arguments follow a pretty consistent pattern.
A pattern. Okay.
First, they lay out the conditions for what counts as a good way to measure epistemic utility.
Like ground rules for the utility function.
Right. We call these conditions E.
E for epistemic, I guess.
That sense. Then they take a standard norm from regular decision theory,
Okay.
like a well-established principle of rational choice, and apply it using this epistemic utility function.
So they're taking a rule about making good choices and applying it to the realm of beliefs.
Precisely.
Yeah.
And the link between those conditions on epistemic utility and the resulting epistemic norm often relies on a formal theorem.
A theorem. So we're getting mathematical here.
Sometimes, yeah. It demonstrates that if your epistemic utility function satisfies these initial conditions, then applying this principle of rational choice leads to a specific rule about what to believe.
Oh, that's interesting. So it's like building a logical argument with math as the backbone.
It can be quite rigorous.
Okay. And the SEPI entry uses our George Eliot example. They call it consistency 2 to illustrate the structure.
Yeah, that's a great example. Let's break it down.
So remind us, what's consistency 2 again?
It's the idea that if you have two propositions that can't both be true, you shouldn't believe both of them.
Okay, that makes sense.
Right. So the argument goes like this. Let's say believing a true proposition gives you some positive epistemic utility. Let's call that R.
R for being right.
Exactly. And believing a false proposition gives you some negative epistemic utility.
A penalty for being wrong.
We'll call that W.
So W is like the cost of being wrong.
That's it.
Now let's add in this idea of epistemic conservatism.
Epistemic conservatism.
It's the assumption that being wrong is worse than being right, meaning W is greater than R.
You got it. It's like saying the harm of error outweighs the benefit of a single truth.
I can see that. Makes sense.
Right. So now imagine you believe two contradictory things. One has to be true, the other has to be false.
Okay.
Your total epistemic utility is going to be RW, which is negative because W is bigger than R.
So you're always in the red, epistemically speaking.
Exactly. And even if both propositions are false,
It gets even worse.
it does. Your utility is negative 2W, even more negative.
Ouch.
So in any scenario where at least one of those beliefs is false, your epistemic utility takes a hit.
So believing two contradictory things always puts you in a worse position than what?
Then suspending judgment on both.
So just saying, I don't know about either one.
Exactly.
Yeah.
Because if you suspend judgment, your utility is 0.
Which is better than any negative number.
Right. So suspending judgment dominates believing both.
Meaning it's always the better epistemic choice.
And according to the principle of dominance, you shouldn't choose a dominated option.
So believing two contradictory propositions is irrational.
Boom. There's your argument.
Okay, I see the structure now. It's about showing that breaking this epistemic rule always leads to a worse outcome.
Based on how we define epistemic utility and this core principle of rational choice.
Pretty neat. And the SEP entry then goes on to talk about all the different ways philosophers model epistemic states.
Right, because how we represent those states matters.
So what are the main models they consider?
Okay, first up, we've got the outright belief model.
Outright belief. Like just plain believing something.
Exactly. You either believe it or you don't.
Yeah.
No in between.
Pretty straightforward. That's how we usually talk about belief in everyday life.
For sure. Like, I believe it's going to rain.
Yeah.
Or I don't believe in ghosts.
Simple.
But then you have the precise credence model.
Precise credence. That sounds more nuanced.
It is. This model uses a credence function,
Or function.
which assigns a number between 0 and 1 to each proposition.
So like a probability.
Exactly. 1 means you're absolutely certain it's true, 0 means you're certain it's false, and everything in between represents your degree of belief.
That makes a lot of sense. It captures how confident we are.
Yeah, much more fine-grained than just believe or don't believe.
And this is big in Bayesian epistemology, right?
Huge Bayesian epistemology is all about updating our beliefs based on evidence. And that requires thinking about degrees of belief.
Okay, makes sense. What are the other models?
We've also got the comparative confidence ordering.
Comparative confidence. So instead of numbers,
It's about ranking propositions.
based on how confident you are in each one.
Exactly. Like saying, I'm more confident it'll rain than that it'll snow.
So it's more about the order of your beliefs rather than exact numbers?
Precisely.
Yeah.
And lastly, we have the imprecise credence model.
Imprecise credence. So like when you're not totally sure how confident you are.
Yeah, this model uses sets of credence functions
Sets of them.
to represent situations where your belief is kind of vague or you're okay with a range of probabilities.
Like saying, I think there's between a 60% and 80% chance of rain.
That's the idea.
Hmm.
It acknowledges the fuzziness that can exist in our beliefs.
Okay, so we've got 4 models. Outright belief, precise credence, comparative confidence, and imprecise credence.
That covers the main ones.
And what's cool is that epistemic utility theory can work with any of them.
That's right. You just need to define the right kind of epistemic utility function for each model.
So it's a versatile framework.
Very much so. It can handle all sorts of different perspectives on belief.
Okay, let's dig a bit deeper into the outright belief model.
Right.
The Sempus entry mentions this thing called the Janesian epistemic utility assumption.
Named after William James.
Yeah, what's that all about?
It's basically a way to assign epistemic utility within this model.
Okay, how's it work?
Well, it says if you believe something true, you get a positive utility of R.
R for right,
Yeah.
right?
And if you believe something false, you get a negative utility of W.
W for wrong.
Right. And the total utility of all your beliefs is just the sum of the individual utilities.
So true beliefs are good, false beliefs are bad, and you add it all up.
Simple as that.
Makes sense. And then the SEPI entry revisits that dominance argument for consistency, too, within this Jamesian framework.
Yeah, remember that whole thing about contradictory beliefs?
Right, right.
Well, they apply the Jamesian utilities and the principle of dominance to show that believing two contradictory things is irrational.
Because it always leads to a lower total epistemic utility.
Exactly. And then they introduce this principle of maximizing subjective expected utility.
Now, that sounds familiar from decision theory.
It is. It's a key principle for making rational choices under uncertainty.
So how does it apply to beliefs?
Imagine you have a certain degree of belief in a proposition.
Like a 70% chance of rain.
That's your credence.
Right.
Then your credence in the opposite proposition
No rain.
would be 30%.
Right. Got to add up to 100%.
Exactly. So now we can calculate the expected epistemic utility of believing the first proposition.
By taking a weighted average of the utilities of being right and wrong.
You got it. Weighted by your credences.
So it's like considering both possibilities and how likely you think each one is.
That's the heart of expected utility.
Okay, I'm following.
And this leads to what's called the expectation theorem for the Lockean thesis.
Lockean thesis. Now that rings a bell.
Yeah, it's named after John Locke.
The philosopher, right?
Exactly. The Lockean thesis basically says you should believe a proposition if your credence in it is high enough.
Okay, so there's some threshold for belief.
And the expectation theorem gives us a specific candidate for that threshold.
Based on the Jamesian utilities.
That's right. The threshold is W divided by R plus W.
So it depends on how much worse being wrong is compared to how good being right is.
Precisely.
And this theorem says if your credence is higher than that threshold, you should believe the proposition.
Because believing it maximizes your expected epistemic utility.
Compared to suspending judgment.
Right. And if your credence is lower than the threshold, you should suspend judgment.
Makes sense. So it's like a formal link between degrees of belief and outright belief.
Exactly. It connects those two models.
Yeah. And this has some interesting implications for the whole debate between the uniqueness thesis and epistemic permissivism, right?
Oh, yeah, it does.
Big time.
Remind us what those are again.
The uniqueness thesis says there's only one rational way to respond to a given body of evidence.
Like there's only one right answer?
Epistemic permissivism says there might be multiple rational responses.
More than one way to be right.
Exactly.
So how does epistemic utility theory play into this?
Well, even if we accept the uniqueness thesis for credences.
Meaning there's only one rational credence to have.
Right. Even then, people might have different values for R and W.
Different utilities for being right and wrong.
Which means their locking thresholds will be different.
So even if everyone agrees on the right credence to have,
They might disagree about whether to believe the proposition outright.
because their thresholds are different.
Exactly. One person might believe it while another suspends judgment, even though they have the same credence.
That's fascinating.
Yeah.
So it suggests that rationality allows for some flexibility in our beliefs, a certain degree of permissiveness.
Not just about the evidence, but also about our individual values.
That's right.
Now, what about extending that consistency to idea to more than just two propositions?
That's where things get a bit tricky.
How so?
Well, the full consistency principle says if you have any set of propositions that are logically incompatible, you shouldn't believe all of them.
So it generalizes consistency.
Exactly. But the simple dominance argument we used before doesn't quite work for larger sets of beliefs
Why not?
because of that Lockean threshold. Remember?
Yeah, W divided by R plus W.
Right. Imagine a lottery with a ton of tickets. Only one can win.
Okay.
The propositions ticket 1 will lose, ticket 2 will lose, and so on are all inconsistent.
Because they can't all be true.
Right. But if your Lockean threshold is low enough,
And your credence in each of those propositions is high enough.
then you should believe each one, even though they're inconsistent as a set.
So maximizing expected utility might actually lead you to believe inconsistent things.
In some cases, yeah,
That's interesting. So the dominance argument for full consistency runs into problems.
it does, unless we make some strong assumptions about how much we value avoiding falsehoods.
Like making W really big compared to R.
Exactly. Then the threshold becomes so high that you're less likely to believe a whole bunch of inconsistent things.
Okay, so generalizing consistency is more complicated than it first seemed.
It definitely is.
Then the SEP entry mentions Rothschild's argument for almost lock-in completeness for belief sets.
Yeah, that's a bit of a mouthful.
What's the gist of it?
Well, it's about how your beliefs should relate to some hypothetical credence function.
Even if you don't actually have precise credences.
Exactly. It's about the coherence of your beliefs.
Okay.
Rothschild uses a version of the dominance principle
Okay.
and this idea of a uniform ratio of epistemic utilities.
Uniform ratio, meaning?
The ratio of the cost of being wrong to the benefit of being right is the same for all your beliefs.
Okay.
And he shows that if your belief set satisfies this almost lock-in completeness condition,
Yeah. Meaning it's consistent with some hypothetical lock-in threshold.
then it won't be dominated under any set of utilities with that uniform ratio,
So it's like a way of ensuring your beliefs are kind of internally consistent.
even without precise credences. That's the idea.
But the SEP entry also points out a potential issue with this argument.
Right. It asks why you should care about being dominated relative to utilities that aren't actually yours.
Like, why should your beliefs be constrained by someone else's values?
That's a good.
Yeah.
That's a good question.
Okay, so we spent a lot of time on the outright belief model.
It's a foundational one for sure.
Let's shift gears and talk about the precise credence model.
All right. Time for some probabilities.
The SEP entry discusses epistemic utility functions specifically designed for credences, like the Breyer score.
The Breyer score is a classic.
What are those and why are they important for this model?
Okay, so with precise credences, we're dealing with entire probability functions.
Right, not just single beliefs.
So our utility functions need to take those entire functions as input.
And spit out a number representing how good that credence function is.
Exactly. And the Breyer score is one way to do that.
Okay, how's it work?
It's based on this idea of a scoring rule,
Scoring rule.
which assigns a utility to having a specific credence in a single proposition.
So it's like a mini utility function just for one belief?
That's a good way to think about it.
Okay.
One common scoring rule is the quadratic scoring rule.
Quadratic scoring rule.
Yeah, it's a bit mathy. But the basic idea is that the closer your credence is to the truth value of the proposition, the higher your score.
So if something's true and you have a credence of 1, you get a perfect score.
Exactly. And if it's false and you have a credence of 0, you also get a perfect score.
So it rewards you for being accurate.
Precisely. And the Breyer score for your whole credence function is basically the average of your scores for all the propositions you care about.
So it measures how close your overall beliefs are to the truth.
Exactly. It's like a measure of your overall accuracy.
I see. And the SEP entry mentions some important properties these scoring rules and utility functions can have, like continuity and strict propriety.
Those are key properties.
What do they mean in this context?
Well, continuity basically means that small changes in your credences should only lead to small changes in your utility.
So it's a smoothness condition?
Right. No sudden jumps or discontinuities.
Okay, what about strict propriety?
That one's super important. A scoring rule is strictly proper if the best way to maximize your expected score is to report your true credences.
So no benefit to lying or exaggerating your beliefs.
Exactly. Honesty is the best policy when it comes to strictly proper scoring rules.
That seems like a good thing for an epistemic utility function.
Absolutely. We want a measure that encourages us to be truthful about our beliefs.
And for utility functions that cover all your credences.
Strict propriety means that a probabilistic credence function will see itself as the best option,
It expects to do better than any other credence function.
on average according to its own probabilities.
That's interesting.
It is. There are also properties like extensionality and additivity.
What are those?
Extensionality means that the utility only depends on the truth values of propositions, not how those propositions are described.
Okay, so the wording doesn't matter, just the truth.
Right. And additivity means that the total utility is just the sum of the utilities of individual beliefs.
So each belief contributes independently to the overall utility.
Exactly.
Now, the SEPI entry points out that there are arguments for why these properties are desirable, often based on this idea of veritism.
Veritism is a big deal in epistemology.
What's the main idea behind it?
Veritism says that the only thing that matters epistemically is accuracy.
How well our beliefs match reality.
Precisely. And from a veritist perspective, these properties like strict propriety are important because they ensure that our utility functions are good measures of accuracy.
So they help us track truth.
That's the gist of it.
And there are a bunch of philosophers who've made arguments along these lines.
Yeah, people like Joyce Light, Gebb, Pettigrew, Degas, Delizino, Senegalia, Levenstein, Kerbel. They've all contributed to this veritist approach.
But are there also arguments for these properties that don't rely on veritism?
Yes, there are. Some philosophers like Joyce have argued that strict propriety is essential for any measure of epistemic utility, regardless of whether you're a veritist or not.
Interesting. So it's a more general principle of rationality.
The idea is that if a utility function isn't strictly proper, then you might end up thinking some other credence function is better than your own.
Even though you're using your own probabilities to evaluate them.
Exactly. And that seems kind of irrational.
It does, yeah.
But of course, this argument has its critics.
People who disagree.
Philosophers like Hayek have raised objections, and Pettigrew has defended and refined Joyce's position.
So it's an ongoing debate.
It always is in philosophy.
But it's good to see these different perspectives.
Absolutely. It helps us sharpen our understanding.
And of course, there are also objections to these characterizations of epistemic utility functions.
All right, people who challenge the emphasis on accuracy and propriety.
Like who?
Well, there's the varying importance objection, for example.
Varying importance. So the importance of being accurate about something can change.
Depending on the situation.
Right.
Like being accurate about whether your loved one is safe is way more important if they're in actual danger.
Than if they're just at home chilling.
Exactly. And this objection says that standard accuracy measures don't capture this context sensitivity.
Because they treat all propositions the same.
Right. That's the critique.
Then there's the verisimilitude objection.
Ah, yes. Verisimilitude. It's a fascinating concept.
What's it all about?
It's the idea that sometimes a false belief can still be close to the truth.
Like it's on the right track, even if it's not perfectly accurate.
Exactly. And this objection argues that accuracy measures like the Breyer score don't capture verisimilitude.
So they might miss out on some important epistemic value.
That's the worry.
Interesting. And finally, there's the numerical representability objection.
This one's more about the foundations of the whole approach.
How so?
Well, it questions whether we can really use numbers to represent epistemic utility.
Like maybe it's not quantifiable?
That's the idea. The objection says that to justify using numbers and doing calculations with them, we need solid support from measurement theory.
Which basically tells us when and how we can measure things.
And the objection claims that epistemic utility theory often lacks that rigorous foundation.
So it's a challenge to the whole enterprise.
In a way, yeah. It's asking us to really think about what we're doing when we assign numbers to epistemic value.
Okay. Those are all important objections to keep in mind.
Definitely. They show that this area of philosophy is still under development.
Now, the SEP entry then gets into what's probably the biggest application of this framework. Arguments for probabilism.
Probabilism, the cornerstone of Bayesianism.
Right, the idea that rational credences have to follow the rules of probability.
Exactly.
So how do epistemic utility arguments support probabilism?
They aim to show that any credence function that breaks the rules of probability is worse than some other credence function that follows the rule.
From the standpoint of epistemic utility.
That's right. And they often use this principle called undominated dominance.
Undominated dominance? Another mouthful.
It basically says if there's an option that's better than yours in every way, and that option itself isn't worse than anything else, then you shouldn't choose your original option.
Okay, so it's like a refined version of regular dominance.
Precise.
And the big result here is the dominance theorem for probabilism.
It's a powerful theorem.
What does it say?
It says that if your epistemic utility function is continuous and strictly proper, then any credence function that violates the probability axioms is dominated.
By a credence function that does follow the axioms.
Exactly. And no probabilistic credence function is dominated by a non-probabilistic one.
So it's like saying if you want to maximize your epistemic utility, you got to be probabilistic.
That's a good summary.
But of course, there are objections to this argument, too.
Right. There always are.
Like what?
Well, there's the different dominators objection.
Different dominators.
It says that different utility functions might pick out different probabilistic credence functions as the dominators.
So it's not clear which probabilistic credence function is the best.
Exactly. And that weakens the argument a bit.
Makes sense. Then there's the evidence and accuracy objection.
This one's interesting. It says that if your non-probabilistic credences perfectly reflect your evidence, then the fact that they're dominated by probabilistic credence functions might not matter.
Because those probabilistic credence functions might not fit your evidence as well.
Right. So maybe sticking to your non-probabilistic credences is still rational.
If they're really true to your evidence.
Exactly.
Interesting. And the last objection is the dominance and act state dependence objection.
This one gets a bit complex.
Okay, I'm ready.
It's about situations where your beliefs can actually affect the state of the world.
So like a self-fulfilling prophecy.
Kind of. In those cases, the usual assumption that actions and states are independent breaks down.
And the dominance argument might not apply.
Exactly.
Okay, so even the seemingly strong argument for probabilism has its nuances.
It definitely does. It's a rich area of debate.
Now, the SEPI entry also briefly mentions epistemic expansions and infinite probability spaces.
Right. Those are important extensions of the basic framework.
What are the key points there?
Well, epistemic expansions are about comparing credence functions that are defined over different sets of propositions.
So, like, you're expanding the range of things you're considering.
Exactly. And this can lead to some tricky issues with dominance arguments.
Like infinite regresses.
Potentially, yeah. It's like a rabbit hole of comparisons.
And infinite probability spaces are even more complicated.
They are, because you have infinitely many propositions to worry about.
So how do you even define epistemic utility in that case?
It's a challenge.
Hmm.
But philosophers have made some progress.
Like who?
People like Walsh-Kelly and Nielsen. They've extended the Breyer score and the dominance theorem to certain infinite cases.
So probabilism might still hold up, even in those situations.
That's what the research suggests.
Okay, and lastly, in this section, the SEPI entry mentions non-classical logics.
Right. What happens if we change the underlying logic?
Yeah, how does that affect things?
Well, if we move away from classical logic, the standard arguments for probabilism might not work anymore.
Because they rely on certain assumptions about classical logic.
Exactly.
So what happens then?
Philosophers like Williams have explored this. They've shown that in some non-classical logics, the credence functions that avoid domination are those that satisfy generalized probabilism.
Generalized probabilism. So it's like an adjusted version of probabilism.
That's a good way to put it.
Hmm.
It takes into account the specific rules of the non-classical logic.
Okay, so the logic we use really matters.
It sets the stage for what counts as rational belief.
Makes sense. Now, the SEP entry also touches on epistemic utility arguments for chance credence norms, like the principal, and for conditionalization.
Those are both big topics.
We could do whole deep dives on each of them.
Easily.
But what are the main connections to epistemic utility?
Well, the principal principle is about how our beliefs about chances should relate to our beliefs about the outcomes of chance events.
So, like, if I believe there's a 50% chance of flipping heads,
then my credence in the proposition, the coin will land heads, should also be 50%.
okay, that makes sense.
And the source notes that if we assume chances are not modest,
Meaning we're pretty certain about the objective chances?
then we could use epistemic utility arguments to support the principal principle.
By appealing to things like continuity, strict propriety, and undominated chance dominance.
Exactly. But it's important to remember that these arguments often don't tell us why we should defer to chances in the first place.
They just tell us how to respond if we do.
That's right.
Okay, and what about conditionalization?
Conditionalization is all about how we update our beliefs when we get new evidence.
A crucial part of Bayesian epistemology.
Absolutely.
So how does epistemic utility fit in?
Early arguments focused on partitional plan conditionalization, which planning in advance how you'll update your beliefs based on whatever evidence you might receive.
Okay, so you have a plan for each possible piece of evidence.
Right. And the expectation theorem shows that these conditionalizing plans maximize expected epistemic utility.
Assuming strict propriety.
Exactly.
Yeah.
And there's also a dominance theorem for this type of conditionalization.
So it's like saying the best way to plan your belief updates is to use conditionalization.
That's the idea.
And more recent work has focused on justifying diachronic conditionalization itself, which is updating your beliefs when you actually get the evidence.
Right. And those arguments often look at which posterior credence function maximizes expected utility from the perspective of your prior beliefs.
Okay, so it's still about maximizing expected utility, but in a more dynamic setting.
Exactly. It takes into account the flow of evidence over time.
Makes sense. Now, the SEP entry then delves into how epistemic utility connects to the uniqueness thesis, but now focusing on credences.
Right. So now we're asking, is there always a single uniquely rational credence to have?
Not just belief, but degree of belief.
Exactly.
Okay.
And this is where attitudes towards epistemic risk come into play.
Epistemic risk. So, like, the risk of being wrong.
Precisely.
So how does that connect to the uniqueness thesis?
Well, if you're